Do tell me whether is it visible to all of you?
Yeah, sir, it is visible.
Okay.
Clearly visible, sir.
Okay. I am moving my cursor. Is it moving like that?
Yeah, sir, it is moving.
I click on accessories. Here comes the accessories.
Yes, sir.
Are you able to
Yes, sir.
see this?
Yes, sir. Yes, sir.
Okay. Okay. Sensitive analysis is basically to see whether we are in model's behavior is properly or not, whether it is useful for us or not. This is the main funda behind to carry out the sensitivity analysis. And moreover, one thing you can calibrate the genetic quotient by means of using GenClu. GenClu doesn't provide a results as far as calibration of the coefficients is concerned. So you can use the sensitivity analysis. Actually, it gives us the performance of the model, the behavior of the model for any of the factors, whether the model is, for example, if we are changing something, model is showing change or not. It is responding to us, our change or not. It is for that purpose. Huh? You have to sensitivity analysis. Is it visible? The green is visible? No.
Yes, sir. Yes, sir. It is visible. Yeah.
Which one? Which one? Which one?
Sensitivity analysis and
DSAT sensitivity analysis version 4.7.5. Is it visible?
Yeah. Yes, sir. Yes, sir.
Okay. So, as far as crops are concerned, there are almost 32 crops in it. Whatever the experiments, whatever the sensitivity on which crop you are going to carry out, you have to open the sensitivity analysis. After opening this screen will pop up. Then you have to choose a crop. Are the crops visible?
Yes, sir.
Read
Cereals,
out.
legumes, root crops.
No. I have to change the screen. That's what
Okay.
I'm asking.
Okay, sir.
That is what I am asking. Okay, now it is visible?
Yes, sir. Yes, sir. General experiment source properties, genetic culture.
Once I click the sensitivity analysis, this screen will pop out. Right?
Okay.
Do tell me, be with me. Huh? If I will click here,
Yes,
there are almost all the crops, whatever the crops are in DSAT, almost you find all the crops here. Huh?
Yes, sir.
Are you able to see these?
Yes,
Are you able to see these?
Yes, sir. Yes, sir.
Okay.
Yeah.
For example, if I want to carry out the analysis of any one of the crops, for example, I will click here wheat. Are you able to see it? Wheat?
Yes, sir. Yes, sir.
All the experiments which are in the DSAT, in the wheat, they comes here. Now you have to look in which experiment you want to carry out the sensitivity analysis. Huh? Right?
Yes.
There are 4 experiments.
Yes, sir.
There are 4 experiments. First one is wheat, KSAS 8101, POR 07401, SW 7501. Then Toby, this experiment I have carried out for one of the PhD students of she is from China, working on different scenarios and all that. Actually he's from Pakistan but doing PhD in China. He's working on wheat Saraswati model. So I will open this experiment. I have already created this. I will open this experiment. Okay. We can see here, this is with respect to different fertilizer doses, this experiment. Huh?
Yes, sir.
Right? We can check all these, or we can go for sensitivity analysis of one single dose. For example, we are interested to see the effect of only fertilizer and 136 kg per hectare, right? If I will take all these treatments, then I have to it will be a lot of combinations because I have to take the genetic coefficients from left side. It will make a lot of combinations. Instead of taking all these, I will take treatment one. Okay, I will uncheck all these. Huh? So this is the
Okay,
fertilizer
sir.
one. Okay, right?
Yes,
Then,
yes, sir.
then we will go from left side. You can see here general experiments, source properties, then cultivars, genetic food coefficients, planting, fields, soil properties, weather. These are the categories, different categories. I will open the genetic coefficients. Like,
Yes, sir.
is it visible?
Yes, sir.
Okay. So as far as wheat is concerned, these are the genetic coefficients. These are the genetic coefficients of all these varieties. Naganda, China. I have
Yes,
calculated
sir.
these coefficients for Naganda, China. You can see here in template. You are able to see my cursor where I am moving from.
Yes, sir. Template cultivar. It is a
Template
template
cultivar.
cultivar.
China,
Yes, sir.
Naganda 211. I have already calibrated and validated these genetic coefficients for the student. That one. So I'll use this experiment. How to use it now? For example, you can see here coefficient value P1V. P1.
V.
Okay. First one is P1
V.
V. For this variety, I have calibrated the value 45. You can see here different
5.
varieties have different values, right?
Yes, sir.
Oh,
Yes,
okay.
sir.
So you can put some starting value. There are some starting values. Shall I open that genetic quotient file? You want to see that? Wait, I will open that. I will show you. Are you able to see this screen now?
Yes, sir.
Okay. These are
Wheat
the
cultivar file. Yes, sir.
yeah, wheat cultivar file. This is actually. So these are the genetic
Yes.
coefficients of wheat: P1, V, P1D, P5, G1, G2, G3, and FINT. Every coefficient has its own values. For example, if you see here, the description is already given. P1 is the day's optimum volatilization temperature required for volatilization period, right? Because
Yes, sir.
why it is valorization? You grow wheat in the summer season, right? Because this is for winter wheat, yeah? Right? Valorization temperature is required. P1 do its own description. P5 grain filling. G1, that means P1 and P2. These are for vegetative phase. Huh? P1 and
Yes,
P2.
sir.
Then P5, it starts grain filling stage, excluding lag. The description of each and every coefficient is given. But you can see here, see here, minimum,
Yes, sir.
maximum. What is the
Maximum.
minimum
Yes,
value
sir.
of P1V?
0 to 60.
0 to
Minimum
60.
0.
Yeah, P1D is 0 to 200, as is 200. P5
Yes,
100
sir.
to 999. G1 10 to 50. G2 10
Yes,
to
sir.
80. G3 0.5 to 8. And FINT is 30 to 150. So you should
Yes, sir.
always do one thing. You should take a pen copy, or you should keep it open as file, so that you will see what is the minimum value and what is the maximum value.
Maximum. Yeah.
Okay. Coming back where I was. Okay. Okay, I'm coming back. Green is visible.
Yes, sir.
Okay. So I will touch first P1V, right? P1V.
Yes, sir.
What was the starting value?
0 to 200.
0 to,
Let's see, 200.
no, it's 60. Starting value is 0.
Okay, okay, okay.
Starting value is 0. Now, the number of increments you want to perform the model. Increments you want, let it be what? 60.
60.
Depends upon you. Increment depends upon you. 60 means it will only be two results of two, one for 0 and one for 60. Let us make an increment of 5. So how many will be the iterations? 60
12.
divided by 5, that is
12.
12. The number of iterations will be 12. Iterations means how many will be the your highest value and what are the increment giving. We can give increment here 1 by 1 also. That means the iterations will be 60. Suppose if I will give here increment 1. Okay, I want to start from 0 to 60. 0, 1, 2, what will happen with the crop? 0, 1, 2, 3, 4, 5, 6, up to 60. The iterations will be how many?
60.
60, right?
Yes, sir.
If you want decimal place, you can put decimal place. If you don't want, you can ignore it. Then I will say, click here, go. Are you able to see it, the screen?
Yes, sir. Yes, sir. 60.
61 will be there because 0
61.
is
60.
60, 0 will be also included. 0 is here.
Yes, sir. Yes, sir.
Okay. I will ask this sensitivity analysis to create experiment. What? We have to click it. If earlier I told there were many treatments of nitrogen, but I only selected one treatment. If I will select 4 treatments, 60 multiplied by 4, that will be 200. 40 will be the 240 would have been the here. The results once we get those will be of 240 because I have checked only one treatment from experiment. That is why it's getting like this. Otherwise, we can do multiple. We can use multiple treatments also, and we can check it. Right?
Yes, sir.
This is a sort of an example I'm showing you. Then you have to click here, create experiment.
Yes, sir.
Okay, this will be saved in sensitivity work. My sensitivity work will be 1401.whx, right? The name will be saved. Wait experimental file. Okay, save. Do you want to overwrite old file? Okay. Okay, we have saved now experiment. This is experiment now. This is now our experiment. It's not in DSAT. We are in sensitivity analysis, right?
Yes,
so
sir.
Next step will be run the model. Okay. Now it's running up. Sulekha is not responding. She has muted the mic.
Sulekha, mic unmute kar do.
Yes, sir.
Are you able to get it? Or you are doing simultaneously? Yes, you are doing simultaneously with me.
Yes, sir.
You are doing simultaneously with me in parallel mode. You are doing also or not? Yogesh, are you doing?
Yes, sir.
Yes, sir.
Don't worry.
Yes, sir.
Don't worry about that.
Yes, sir.
If you want to have an exercise on parallel mode also, then I will share the files with you. We'll upload those files in your DSAT program. Then we can do in the parallel mode also, because you will not have this type of file in your DSAT mode, no? That has
Yes, sir.
Either we can take once we install the DSAT, already the files are there now. We can take any file which is with you as well as with me. We can select out of that any file, and we can do this in a parallel mode.
Yes, sir.
Yes, sir.
सर ये जो हमारी ये एक वैरायटी है, एक जो भी हम वीट की वैरायटी ले रहे हैं,
Yeah.
उसमें हम जो वीट की वैरायटी जब हम जीनोटाइप कोफिशिएंट बनाते हैं तो वो पूरा प्रॉपर मतलब 1-2 साल का एक्सपेरिमेंट किया जाता है, फील्ड एक्सपेरिमेंट, तब जाके बनाई जाती है। तो हम उसको चेंज क्यों कर रहे हैं सर?
योगेश, जब हम
यस
एक्सपेरिमेंट क्रिएट करते हैं तो एक्सपेरिमेंट क्रिएट करते हैं नॉट फॉर जेनेटिक कोएफिशिएंट्स एंड ऑल दैट, दैट इज फॉर वैलिडेशन। तो मॉडल है ना, मॉडल है 3 पार्ट्स। फर्स्ट वन इज calibration, second one is
यस सर,
validation,
वैलिडेशन।
third one is simulation or you can say evaluation, like that. क्या होता है कि फर्स्ट वन हमारा कैलिब्रेशन है, until and unless you will not calibrate your model, it is of no use. Calibration means simply, I will tell you one thing. For example, you are using pH meter, right? You are using pH meter.
यस
How
यस
to
सर।
calibrate your pH meter? कैसे करते हैं calibrate pH meter को? Do you know, Sulekha? How we calibrate? Okay, I want to know your background. You are from which discipline? PhD?
सर आई एम फ्रॉम एनवायरनमेंट।
Environment. Okay. Sulekha?
यस सर।
Sulekha,
Sir, yes, sir.
your specialization is
रिमोट सेंसिंग।
oh, remote sensing. तो मुझे मैडम से
Yes, sir. Geoinformatics, sir.
Okay, geoinformatics. Okay, that's. I'll tell you one thing. Once we calibrate any machine, for example, I will take an example of pH meter. What we do, we put on pH meter, then we put a buffer tablet in a beaker, buffer known buffer, for example, 4. We fine tune with the knob that pH meter should show us result 4, right? Then we put 7 buffer tablet of 7 dissolved in a water. So we fine tune that pH meter that it shows the result 7. Then we put another tablet of pH 9. So pH meter should show us 9. If it's not showing, we'll fine tune this. Once we will calibrate our pH meter with these 3 tablets, then you put any of the samples for testing it. It will give you the results of pH of that solution. That is the calibration part. Modeling, what's the calibration part? For example, rice is our yield here under temperate conditions or Kashmir conditions. Rice is near about 50 to 60 quintals per hectare. If my model is showing 120 quintals, it is showing 20 quintals yield. That means our model has not been calibrated properly. It has not been. Sometimes it shows the results 0. That means it has not been calibrated. Then comes the part of validation. Validation with the observed. Validation means whatever the results we get from a simulated run model and whatever the observations we get from the field, those are compared. Whether using Excel, whether using Origin Pro, those results are compared with each other. How many variation is there? Variation is the difference between the observed and the simulated is within the acceptance or not. That is the validation part. That is the validation part. If it is 10 to 15% difference is there, it's okay. I can say it's okay. Okay with me, because R-square value tells you how much accurate you are while running the model. Once for that, I have to take a separate lecture for that, how to carry out the validation part in Excel and all that. Okay, let's coming back to my portion. Simulation has been completed. Okay, I will. Okay, simulation completed. Now I will analyze. These are the output files, right? These are output files. If I will click one of the file, summary, view, see here. Are you able to see my screen or shall I change?
No, sir. Actually, summary.out it is visible.
Which one? Which one?
Summary dot out. You have select na summary dot out.
Selected. Okay.
Science work. Yes. Sir.
Okay. Here comes the summary. Summary.
Yes, sir. Yes, sir. It is visible now. Summary.
Visible to all?
Beijing, China.
Yes, sir.
Okay. See here. Runs. How many runs? Starting from here.
61.
61 runs. Okay.
61.
Okay. Treatment 1, 2, 3, 4, 61.
Yes,
This is the model, Ceres model. This is the experiment name. See here, treatment what we have done, 0. That means we
Yes,
put
sir.
the value
0 to
P1
60.
at 0, then what 1, then 2, then 3, 4, 5, so on and so forth up to 60.
60.
It has given us the results. Now come direct to the results. We can see here. See here.
Yes. Yes, sir.
This is the harvest weight at HWAM, harvest weight at maturity. Or you can see here harvest if we are interested in harvest. If we are interested in maturity date only, if we are interested in antithesis day after transfer, antithesis day only, you can check here. Planting date is here. All of you know some codes, little bit codes of result output file. You are aware of all these results output file? No.
Yes, sir. Yes, sir.
You are, huh? Okay. So suppose we are interested here. Harvest weight at harvest or harvest weight at maturity.
Maturity.
You can see here the difference. While increasing the value, here the B1 value was 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. You can set your, you can see here 34 quintals, 33 quintals. That means my maximum yield, if I am interested to put that, you can say P1 value in the genetic quotient file at maximum yield,
Yes,
or I am talking about yield. Somebody may interest here in antithesis date. 103 days. In first, it took 103 days, huh? 110.
Yes.
112,
Yes.
113, 14, 15, like that, so on and so forth. You can select accordingly the what your P1 value, right? P1 value is here.
Yes, sir.
You can accordingly see. You can accordingly select the P1 value here. For example, for Toby variety, as I have selected because in China he sent me the file that was around like maximum fertilizer level. He was getting a yield of 8 tons. 8 tons mean 800 quintals. But this is the minimum fertility level. So I selected for him the time is running out. I need to start again. I selected this 45. You can see here 45.
Yes.
It is giving me highest yield 599.
3,000.
No, it is 3,303 because 34 I am also getting here, but once I change the another quotient, it also gets changed. So you need to change one by one. Which quotient, what value we had to put, because P1 is responsible for our, we can say, vegetative phase.
Yes,
So
sir.
we are interested here, and this is the like here
Planting date.
planting date, and this is
Yes.
80 and this is date. We are interested here. So he gave me the antithesis date. It was coming around like 118. So I selected the value 45, maximum value for him. I put the maximum value for 45 for P1, right? So
Yes,
this
sir.
is the method by which we can carry out the sensitivity analysis. You can carry out the sensitivity analysis with different factors also. Not only with this one. This was one of the example of carrying with the help of genetic quotients. So you can select another experiment. You can go for You can share. You can go for summary. Instead of summary, you can go for plant growth out also. You can check it, plant growth out, plot, right? You can plot the graphs and check whether results are right or wrong. Basically, what we do, we check with the PUBG build only. Whether okay, sensitivity, this is what it is saying about us, why to fix the values and all that. The build is visible or not? No.
Yes.
The build is visible for you. Is it visible?
Let this
Yes,
plant
sir.
grow dot out.
Okay.
Yes, sir. Yes, sir. Now it is visible.
No.
Lot of parameters. If you are interested in checking the leaf area index,
LAI.
then with all these iterations we have created, huh?
Yes, sir.
Yes, sir.
Okay. Next. Time is running out now. That's why I'm getting in a hurry. I need to then understand again. So it will create a graph for me regarding the leaf area index with all the iterations I have prepared with respect to the P1 B value. Huh? It will show me the
Yes, sir.
graphical
Yes.
representations. Huh? Because there are 60 iterations, it will take a little bit time. Huh? If I would have included all the experimental file with different fertility levels, then the number of results would have been multiplied by 4. That means 240.
सर कुछ और क्वेश्चंस भी कर सकता हूँ क्या इसके रिगार्डिंग, मतलब इससे थोड़ा अलग लेकिन डीसेट से रिलेटेड?
Sure. Wait, I want to see. See here.
Okay. Yeah, sir.
Yeah, got it. Leaf area index.
Yes, sir.
area
Yes, sir.
index.
60
You
values.
can see here maximum leaf area index. What line? Almost we can see. Check it here.
Yes.
Here or here. You can see here. Huh?
Yeah.
This is days after
Yes,
planting.
sir.
Because the winter wheat goes around. It takes around 240 odd days to get mature. So maximum leaf area comes here in the month of rather April. So in the month of October comes in the month of April. You can see here right here, or you can check it right here. So you can see below different lines. Which line it is? Red 131. Which is this color? I'm not able to
31.
see. 31. Which value it is here? Which line it is? It is
3 point something.
46 like something, huh? 46 like
Yes, sir.
something. Behind this there will be gray. So that is why I selected the value 45 there. I put the value P1V as 40, P1V as 45. Right here. I can put also 46. It will give the same results. Huh? Hardly there will be any difference. Huh? Now you got how to analyze all these things using this.
Yes, sir. Yes.
Okay. 5 minutes are left in the meeting. Any question? Open for discussion. Otherwise, I will create another meeting. Don't worry.
Okay. So, sir, actually, I just want to ask you another things like how to do irrigation management with DSAT.
Okay. Irrigation management DSAT. You are. Do you have dates? Do you have dates? You have irrigation applied, or you want to carry out an experiment with respect to automatic irrigation system?
Sir, I want to do some experiment by my own.
Okay. You have you prepared the treatment details for that?
Sir, actually, I have done for one village level at district of Meerut, and I have given 5 irrigations.
Okay.
And my results are very good actually it is near about plus minus 5% deviation.
Okay.
But if I have read some paper like irrigation management and irrigation management को हम मतलब कैसे करते हैं DSET में, मतलब वो मैं पूछना चाह रहा था सर.
How to incorporate your irrigation management practice in DSAT and how to get the results, right? Like that?
Yes sir, yes sir.
Okay.
Yes sir, yes sir, yes sir.
For that, I have to take another lecture because I have to open the DSAT again.
Okay, okay, no issue sir, no issue.
But others are there, they are interested. So, Lekha, you got it? How to carry out the sensitivity analysis? How to
Yes, sir.
how to
Yes,
fix?
sir.
Huh? You can make iterations as many as possible, but remember one thing: always there is given minimum and maximum value. Take these for granted, minimum and maximum, and you can make iterations. For example, I made here the iteration difference of 1. You can take it. You can take it iteration difference of 2, 3, 5.
2, 3, yes.
Then iterations
Yes,
will
sir,
be
yes.
less. Iterations will be your graph or overlapped lines will be very less because
Less.
number of runs will be less.
Statements are less.
Number of
Yes,
runs
sir.
will be less. Depending
Less.
upon it depends upon the coefficient you are going to assess. Some coefficients have a value from 90 to 990, like that. You can put iteration value difference 10, 90 के बाद 100, 100 के बाद 110, and divide 990 by the number of your iterations. Difference, you will get the number of iterations. Put number of iterations. I want these number of iterations. So it depends upon generally your maximum and minimum value. Then accordingly divide your iterations requirement. Then you can go through and you can fix your values for example, I can say P1, P12, and all those other genetic options like that. Right?
Yes.
This is the
Yes,
how we carry out the sensitivity
analysis.
analysis. Okay. Shall I start another lecture today, or shall we? You prepare. Yogesh, 1 minute is left. Any question? Any question?
Sir, no, sir. Thank you so much for your
Yes,
precious
sir.
time.
No, I am always here for everyone. Don't worry about it.
Sir, yes, sir. I know, sir. That's why I asked to Dr. Salu Thakur.
Okay. Okay.
सर आपकी वीडियोस देख के भी अच्छा लगता है सर, आप बहुत अच्छे से
I have
एक्सप्लेन
not
करते हैं
uploaded all 10 videos. I have not uploaded because it takes a lot of time. Ask my son keep on video uploading. It takes a whole night him to upload the video. So
yes sir,
tomorrow you prepare what is the amount of water you applied, the dates, okay, right?
yes sir,
Tomorrow you create a Zoom meeting, share with me, same time,
yes sir, yes
and
sir,
we will step by step. I will tell you. You will run in your laptop, right?